Illustrative Math, Algebra 2, Unit 2, Lesson 8 is called End Behavior, Part 1. All right, so our goal today is I can identify the end behavior of a polynomial function by looking at the degree and the leading coefficient. So just a quick review here before we move on. So if I give you a polynomial here, if I call it p of x, let's say it's 4x cubed plus 2x squared minus 9x minus 10. First of all, this one's written in standard form. If I rearrange the terms, you're going to look for the term that has the highest degree. So standard form is always highest power going down. Now, if you skip a power, that's okay as long as they're decreasing in order for powers on your variable. That's standard form. Again, like if it was jumbled up, you go to the highest power term. So that's right here. The 3 is the highest power. So your leading coefficient would be the number in front of the variable. So that would be 4, and our degree would be the highest power. So the degree would be 3. All right, so what is end behavior? That was another word. Let me go back. That was another word here, end behavior, that you've probably never seen. End behavior, degree, leading coefficient. So we check those off. What is end behavior? So end behavior is just what it sounds like. It's the end behavior of your graph, okay? So as I look here, the function shows different end behavior in the positive and negative directions. So to the right, it gets bigger and bigger and bigger. On the left, it gets closer to -3. Okay, and if you look here, here's -3. And you can see, whoops, a little crooked. You can see that your graph is leveling off right here at -3. Okay. They don't always look like that. So, I would say here my left side, for this one, left side approaches or gets closer and closer to, I'll just use the word approaches, -3. Right side gets bigger and bigger, or approaches infinity would be another way you could word that. All right. If I had a graph that maybe looked like this, maybe it had a relative max, a relative min, and then it goes up. Your left side approaches negative infinity. So maybe if I want to abbreviate it and maybe say the right approaches positive infinity. Now, when I say negative infinity, we're talking about the y coordinate. So remember, you got your x and your y axis. Okay, the y axis, if I'm going up, I'm going to positive infinity. And if I'm going down, I'm going to negative infinity. Now, your x axis has the right side goes to positive infinity and the left side goes to negative infinity. But we're always going to say the left is like as I'm going towards negative infinity, and the right is always as I'm going towards positive infinity on the x-axis. Okay, the y's are going to negative infinity or positive infinity. So maybe if I put my y approaches negative infinity for these. Okay, now we can obviously look at a graph and kind of tell which side it's going, but today we're going to do it from just the polynomial. All right, so take a minute, pause the screen, write down some notices and some wonders. Okay, so I think this function here goes with this graph, and then on the right, that function goes with that graph. All right, so what are some notices or what are some wonders? So I'm going to notice here, let's say it is difficult to see the zeros. Okay, if you look in there, I'd probably have to zoom in, or if it was on Desmos, I could click it, but I can't really tell. It looks like this one's at 0. It looks like this one's at 0 too, but it's hard to tell because it's almost like flatlined right there. Okay, another thing, um, I would say the left graph starts low or negative and finishes high or positive. Okay, and I'm saying as I trace this graph from left to right. Okay, so I start down here and I go up. Whereas the right graph starts high, drops to 0, and bounces back up to finish high. I would say the Y scales are very large, but the X scale is not. Okay, you look here, my window for X is like negative 25 to 25, but my Y's are like, negative 10,000 to 10,000 right there. I know it's only marked at 8,000, but and negative 8,000, but the axis goes even lower. Um, so I'd wonder how do the polynomials relate to the graphs? Um, why are the graphs zoomed out so much? To the about this, because back to our goal, I kind of planted the seed here when I was talking about degree and leading coefficient right there. I'm going to say do the degree and leading coefficient affect the graphs? Or I know they probably do. I'm going to say how do the degree and leading coefficients affect the graphs? So when I look at this one, degree is 4, and this one is degree 3. How does that affect it? Okay. Other thing to think about too, I said that it looks like the y-intercepts or the x-intercepts are 0. Just a thing to review here, this constant is 9. So that means you're going to actually, this graph crosses the y-axis at y equals 9. So it's actually like right above the x-axis, but it's zoomed out so far you can't even see it. And same thing over here, your constant's -4, so same idea. This thing actually crosses the y-axis just below, but again, it's zoomed out so far you can't even see it. All right, so here's end behavior. I want you to pause the screen here and write this chart down. So if you have a positive leading coefficient and an even degree, the left side goes up and so does the right side, okay? Or you could think of arrows like that. If it's a negative leading coefficient and an even degree, both sides go down. So the key is even degree, they go in the same direction. Odd degree, they go in opposite directions. So an odd degree with a positive leading coefficient, left side down, right side up, and a negative leading coefficient and an odd degree, left side up, right side down. Now, when I say left side, right side, so like your graph, I'm going to do a little example here. Let's say my graph does a couple things here. Looks like that. I don't really care about the middle. Okay, the middle, I'm not really worried about. I'm looking at the end behavior. So the right end and the left end. The middle part, I'm kind of like not worried about. Okay, so I'm just kind of mentally not looking at those relative max, relative mins. All right, I'm only looking at the end behavior. Okay, so let's go off script from the book here while we're on this slide. I'm just going to write maybe 2 of these here. And we're going to figure out which one of these it goes to. So you look at the degree, even, and you look at the lead coefficient, it's really 1 right there. I know there's no 1 written there, but we know that there's a 1. So that's positive leading coefficient, even degree. So I'm going to move that to right here, this chart. And I know that the left side of my graph goes up, and so does the right side. Okay. If I gave you another one, all right, highest power 3, leading coefficient negative. So negative leading coefficient, odd degree. So that one would be like right here. So my left side of my graph is going to go up, right side goes down. I don't know what it does in the middle. The middle is, oops, the middle is just really like a question mark. I don't really know what it does. And I don't really care for this question here. I don't care about the middle. I just know the left side up, right side down for that function. Same thing over here, left side up, right side up, the middle. I don't really know, and it doesn't really matter for the end behavior. Okay, so let's see it in action. I have a bunch of polynomials here. I kind of already told you the degree and the lead coefficient determinant. So you should know even degree, positive leading coefficient. If you go back to the chart, or you look at the chart that you wrote down, both sides up, positive power, or positive leading coefficient, odd power, should look like this. This one again, this is an even positive again. So this will be just like the first one. And same thing here. This is just like the second one, left side down, right side up. So what I'm gonna do is I'm gonna plug in the numbers here for these functions. I'm gonna plug these in for x, and I'm gonna get the numbers, and I'm gonna fill them into the chart here. Okay, so this might take a second, but I'm gonna type them in here. Hopefully I got enough space to type them. So if I plug negative 1,000 in there, I'm going to get 1,000,001. Okay. And then for the next one, if I plug in negative 100 into this function y equals x squared plus 1, I'm going to get 10,001. And then the next one, if I plug in negative 10, I get 101. I plug in negative 1. Now make sure you plug in the negative 1 with parentheses. I get 2. If I plug in 1, I get 2. Plug in 10, I get 101. I plug in 100, I get 10,001. And then I get 1,000,001. Okay. And then I'm going to go to this function, y equals x cubed plus 1. I'm going to start plugging in these numbers. So here I get negative 999. All right. Next one. Here I get negative 999,099. Plugging them into the function on my calculator. Right, so I basically just plug these values in. I'm going to finish up the chart here, and then we'll talk about it a little bit. All right, and then this last one, I kind of didn't have enough room on my chart, but that's okay. You can kind of see what everything is here. All right, so tables filled in. They didn't quite fully line up, but you can take a look here. I can maybe highlight the rows so you can kind of see which ones go with which. It might help a little bit because it came out a little sloppy. Oops. All right. So, anyways, the key here is take a look here. Let's look at this first one here. The degree is even and the lead coefficient's 1. So as x goes to the left, so as x goes left, you can see here that your y's get bigger and bigger and bigger. So x's are going, think of this as 0 here. As x goes left, my y's get bigger and bigger and bigger. I end up with like a million. And as x goes right, my y's also get bigger and bigger and bigger. So what ends up happening is you get that left side up, right side up. I go over here, left side is getting smaller and smaller. As x goes left, my y's get smaller and smaller and smaller. So that's how I'm going to negative. But then the right side is getting bigger and bigger and bigger and positive. So as x gets bigger, y gets bigger as well. You can see it getting up to, over like a billion, and that would be going up in the positive direction. I go over here, and that's an odd power. Even power again, still leading coefficient positive though. Left side gets bigger and bigger and positive, right side also. So the left side's going up, right side's going up, because these are the y coordinates. And then if it's odd, you see here the left side's getting negative and the right side's getting positive. Okay, so sketch what you think end behavior of your polynomial look like. So I basically kind of did that ahead of time. I kind of cheated and gave you the info, but we kind of proved it there with the table. All right, so the next thing, they give us this polynomial here, which if you distribute everything out, I believe it gives you this in standard form. So here's the thing, to answer the degree, the standard form one's real simple. The degree is 5. If they didn't give you this, you'd have to take the highest power term and multiply all those together. So you're basically going to do x times x squared times x times 2x. Multiply that all out, you get 2x to the 5th, which is what we had here anyways. Okay, so if it's in factored form, you can still find the highest power. So which of these terms for 2 is greatest when x equals 0? So if I plug in 0 for all these, all the ones with the x are going to be 0. So I'm going to get 60. When x is 1, I plug them in, I get 2, I get 5, 30, 5, 88, 6. So this one would be 88x. When x is 3, which one is the greatest? I don't know. I might have to do a little math here. Let me get my calculator out. I'm going to plug in 3 for all of these, and I find out that 30x cubed is the biggest. Okay, plug in 3 for all these values, see which number is the greatest. And then when I plug in 5, I get 2x to the 5th. So basically, if I were to keep choosing bigger x values, okay, this term with the highest power is always going to give us the greatest number, okay? So if I have a polynomial, this term here, the 2x to the 5th, is going to determine what the total value goes towards, if it goes towards a positive or a negative, because the power is so much bigger. All right, so the end behavior, I'm just going to look at the degree. The degree is odd, and the lead coefficient is positive. So right side up, left side down. So I could just say right side, right up, left down. Okay, you could just write it like that, or you could draw this picture. Either way, as long as you know what you're doing, I would accept either of those. All right, synthesis. All right, so we're gonna, if we were in class, we'd do this standing up, but you're gonna stand up and you're gonna move your arms in the right direction after I give a polynomial. So basically, we got a stick figure here. All right, so let's see here. We're gonna look at his arms. I'll make his arms different color, blue. So odd positives, that means that he's going up to the right, down to the left, okay? All right, so let's go to the next guy. Even negative. So even negative, both sides are down. Even positive, both sides are up. And then the last guy, odd negative. So left side up, right side down. Okay? Makes sense? All right, so goal. I can identify the end behavior of a polynomial function by looking at the degree and leading coefficient. I think so. Just go back to that chart that we had at the beginning. So state the degree and end behavior of the following function. Explain or know or explain or show your reasoning. So my degree is the highest power. Degree is right there. It doesn't say to, but I'm going to say the leading coefficient is the other 3, and I'll circle it in green so you see which is which. And that tells me my end behavior. So we have odd, positive, right side up, left side down. Okay. Right, up, left, down. Okay. All right. I hope you enjoyed this lesson. Thanks for watching.